Hello, my name is Mike Ligthart and I'm a PhD researcher at the Vrije Universiteit Amsterdam in the Netherlands. And I'm working on the HERO project, and our aim is to develop a social robot companion for children with cancer. And HERO's main objective is to contribute to stress reduction. And we are working on facilitating a supportive relationship between the child and the robot, and we are developing concrete stress-reducing interventions. And this talk is about one of these interventions, namely interactive storytelling. And HERO has to operate as autonomously as possible to not unnecessarily increase the workload of the hospital staff. And to achieve this, we need a very explicit behavioral design compared to when taking a Wizard of Oz approach. And this is where the interaction design patterns come in. They provide a structured way to specify interactive robot behaviors in such a way that they can be validated, shared with the community, and reused. And these patterns together form a pattern library. And we are expanding our pattern library with the design patterns that can be used in a stress-reducing intervention. During a co-design session with a child life specialist, someone who is responsible for the psychosocial care of the children, we drafted the concept of interactive storytelling as a distractive intervention. And the more the children are engaged by and involved in the storytelling experience, the more effective the intervention will likely be. And this is why the interaction design patterns we have developed focus on supporting children's engagement and agency during the storytelling experience. And agency requires attention, a cognitive component, and is modulated by enjoyment, an affective component. And a positive effect increases the availability of cognitive resources that can be spent on engagement. It is inevitable that a child disengages and re-engages throughout the storytelling experience. It is the robot's ability to re-engage the child that is essential for the effectiveness of the intervention. And to allow children to get more involved with the storytelling activity, we intend to increase their agency. Following the work of Rutt and Koen on interactive digital narratives, we break down agency in this context into three aspects. The feeling of autonomy, experiencing the freedom to influence the story, and the feeling of competence, feeling competent to influence the story, and in this case by communicating with the robot, and affectance, the feeling that your influence actually has an effect or impact on the story. And we don't start with nothing. We have an existing pattern library we developed in future work, which includes design patterns for managing a child-robot conversation. And this includes a recognition and repair pipeline that uses automated speech recognition as a primary input. And in this case, we use Google Dialogflow. And it includes a touch-based repair mechanism. And today, in this video, we will add 3 new patterns to our library. And these patterns focus on supporting children's engagement and agency during a storytelling experience. The first pattern revolves around making choices about the story. It's not only about giving children a direct way to influence the story, it also provides explicit prompts for re-engagement. The problem it needs to solve is to provide meaningful choices while keeping it feasible for the robot to process autonomously, and from a narrative creation perspective, preventing an unsustainable growth of narrative branches, for example. And to address these problems, we opted for a predefined story with fixed decision points, and HERO can keep the initiative by asking for a decision at each decision point. There are 3 types of decisions. The first is a shallow branch, where the child makes a decision that directly affects the next part of the story, but to keep it sustainable, all the branches merge directly after. The second is an alternative ending, so at some point in the story the child makes a decision, and that has an effect on the ending they get. And finally, there are world state variables scattered throughout the story. For example, we have a story about the refrigerator, and a certain fruit plays the role of a DJ inside the party in the fridge. And HERO asks what the child's favorite fruit is and makes that fruit the DJ in the story. Moving on to the second pattern It's where Hero acts out certain scenes from the story it's telling. It uses its full multimodal capacity for motions, sounds and lights to be as expressive as possible. And this supports children's engagement. And Hero furthermore invites children to join in. This allows them to be expressive as well, which in turn supports their own agency. And the third and final pattern allows children to record their own sound effects for the story. So at certain points throughout the story, Hero asks for help for creating a sound effect. Hero records that sound effect and incorporates it into the story. And this supports children's agency. And the use of sound effects in general supports children's engagement. And this is especially true if they made them themselves. We set out to validate the 3 design patterns with a user study. And to not burden the children in the hospital with this first version, we asked 27 school children to evaluate the patterns. The study had a within subject design. Participants were exposed to 2 different stories, one with all the design patterns, which we call the interactive story, and one without, which we call the plain story. And we measured engagement and agency for both stories. To get insights into the participants' agency, we measured the feeling of autonomy, competence and affectance with the player experience of need satisfaction instrument. And because the measures for competence and affectance asked directly about the interaction, it didn't make sense to measure them after a plain story, where there was no interaction. So only for both stories, we measured the feeling of autonomy. The rating of the feeling of competence and affectance will be compared with an artificial baseline. In our paper, you can find more details about that analysis. For now, we will focus only on the feeling of autonomy. We furthermore measured both the attention and enjoyment components of engagement. To measure enjoyment, we asked participants to what extent they would recommend their experience to their friends on a 5-point scale. And to measure attention, we created a light-based distractor instrument. This instrument is based on the prisoner cueing task and the peripheral detection tasks. Both are attention measuring instruments from the cognitive psychology community. And we placed the instruments near the robot in such a way that when the participants would look at the robot, the instrument would be in their peripheral view. The light would come on during 3 fixed moments in the story. And the idea is that the stronger the participant focuses on the attention on the robot, the longer it takes for them to perceive the light. We instructed the participants to push the button whenever they notice the light being on. But we also instructed them there is no need to explicitly keep an eye on the light, and there is no consequences for pressing or not pressing the button, other than that the light being turned off when the button is pressed. And the response times here are indicative of the attention the participants have for Hero. And if we look at the results, we see that participants significantly enjoyed the interactive story more than the plain story, and demonstrating a combined effect of the use of the design patterns. When looking at the results of the light-based distractor instrument, we see that the attention for Hero significantly drops after the first act in the story when no patterns are used. But when the patterns are used, the levels of attention are significantly more stable and significantly higher than when the patterns are not used. And when finally, we find that the participants also feel more autonomous when the patterns are being employed. And summarizing the results, we have shown with our user study that the design patterns combined are effective in supporting children's agency and engagement during a storytelling activity. In the paper, we provide links to our materials if you're interested in using the design patterns in your own work. And besides the effectiveness of the design pattern, we also evaluated design pattern efficiency and user satisfaction. And you can find the details about this in our paper, where we also share a number of lessons learned and insights about the child-robot relationship. The main limitation of the presented work is that we did not evaluate it with children in the hospital. Luckily, we are currently preparing a study to do just that, but more about that in future work. And as a final take-home message, we would like to encourage everyone to build and share their own patent libraries, because I strongly believe that with this collaborative effort, we can drive the field of autonomous social robots forward. Thank you for your attention.